Today we're going to be talking about multiplication word problems. Multiplication word problems are examples of when we can use multiplication in our real lives. From day to day, problems may arise in which multiplication can greatly help you. So these word problems are just practice to get you ready for the real thing. Because in real life, there isn't going to be someone standing there telling you what operation you must be doing. Today, we're also going to be looking at keywords and phrases that can help you understand and realize that multiplication is what you're going to need to do. So let's start with this first problem. There are 6 children at a party. You want each child to have 3 cookies. How many cookies in total do you have to bake? A key word in this problem is the word each. Usually when you see the word each, it implies that you will be doing multiplication. You will be taking a certain number and multiplying it with another number. In this particular situation, we are taking 3 cookies and giving them to 6 children. In order for you to better understand, if you're taking a quiz or taking a test or even in real life, you can draw a picture or use manipulatives to help you get to your answer. So we can scroll down here and we have our 6 children, and each of them here have 3 cookies. So in this given problem, we're going to multiply the 5 children by the 3 cookies that each of them has to get the total number of cookies. Six times 3 is 18. In order to get this answer, it's very important that we remember our multiplication facts and that we're using a multiplication table to study. And also remember that multiplication is actually repeated addition. So you could also solve this problem by multiplying 3, or rather adding 3 plus 3 plus 3 plus 3 plus 3 plus 3, and you would also get 18. However, multiplying is a quicker way to do it. We have another example, and this is a different kind of problem, but also a problem that you might encounter when doing multiplication in the real world. So here's our next problem. You go to an ice cream shop to get an ice cream. They have the choice of a regular or waffle cone. They also have the choice of strawberry, vanilla, or chocolate ice cream. How many different possibilities or options are there? This is a little bit different from the previous question we had. In this problem, we're going to look for keywords that are going to indicate that multiplication is indeed the operation we must complete. So in this particular problem, this word choice right here is an important word. It's indicating that there are options, that we have choices. When you see that we have choices or options or possibilities, that means that we will be doing multiplication to find out how many choices there are possible. So in this particular problem, they also do not give you concrete numbers. You have to really read and pay attention to figure out what 2 numbers we're going to multiply together to get the different number of possibilities. We have a choice of a regular or waffle cone, and we also have the choice of strawberry, vanilla, or chocolate ice cream. I think we should write those down. We have 2 kinds of cones and 3 different flavors of ice cream. This also can be visually represented in a picture down here. We see that up top these are our chocolate, vanilla, and strawberry ice creams in a regular cone, and down here they look a little bit different, but we still have chocolate, vanilla, and strawberry ice cream in a waffle cone. So you're going to multiply the 3 different kinds of ice cream flavors you have by the 2 different options of cones to get 6 total possibilities of ice creams you can have. You could also do repeated addition by doing 2 plus 2 plus 2 in order to get the 6 as well. The same holds true with multiplication word problems that are in the double digits or has a double-digit number. I've included 2 examples just to show you of what double-digit multiplication word problems may look like. This one, for example, says there are 10 boxes. Each box has 4 rocks inside. How many rocks are there in total? How many rocks are there in total? In this as well, we see our keyword each, which means that we're going to be multiplying. And we can see down here that we're going to multiply 10 by 4 to get 40 rocks in total, because we knew from this keyword each that we were to multiply the 2 numbers included. Down here we have a problem similar to the ice cream problem. You have 5 different pairs of pants and 11 different shirts. How many possible outfits do you have to wear? In this problem we have choices, we have possibilities, so we know that we are also going to multiply. In this particular question, we are going to multiply the 5 different pairs of pants you have by the 11 different shirts. So you do 5 times 11 to get 55. I hope this was helpful, and if you have any other questions, just let me know.